We looked at the sum squares of those two, hyperbolic sine and hyperbolic cosine. And now let's look at hyperbolic sine squared minus hyperbolic cosine squared. Yes?
So when you're writing this, do you need the answer as that or the
Which one?
or
Oh, if I have this one?
yeah.
Oh, no. Oh, you can leave it as hyperbolic tangent. Yes, that's perfect. Yes, you can leave it as hyperbolic tangent. That's good enough. Okay, so let's look also at the difference. So this is e to the x minus e to negative x divided by 2 squared and minus e to the x plus e to negative x over 2 everything squared. Let's see what we get now. Again, we get 1/4. Again, I'm going to use the same. So this is e to 2x and minus 2 plus e to negative 2x. But this time minus e to 2x and then minus 2 and then minus e to negative 2x. So these two go away. These two go away. And that's how we get the negative 1. So what we know from trig functions is sine squared plus cosine squared equals 1. But here sine squared, hyperbolic sine squared minus hyperbolic cosine squared is negative 1. So the sum was not positive, or it was not 1, but the difference was negative 1. Okay, let's look at another. Like, it's up to you. What about 30? Please choose if you'd like. F of x equals hyperbolic tangent of 1 plus e to 2x. It's a very good question. We do not have to go back to e to the x and e to negative x unless the problem is asking us to. Hyperbolic tangent or hyperbolic sine and hyperbolic cosine are good enough. Okay, so here again we are asked to differentiate this. So f prime equals, and then we'll look at the word problem to see how this is applied. So we have hyperbolic tangent. So this is hyperbolic secant of 1 plus e to 2x times e to 2x times 2. And you can leave it as is or just rearrange it. 2e to 2x times hyperbolic secant squared 1 plus e to 2x. Okay, let's look at a word problem. And here it is, because I mentioned that situation. Okay, it says a telephone line hangs between two poles, 14 meters apart in the shape of the catenary y equals, and we have, as you see, there is a hyperbolic cosine in there of x divided by 20, where x and y are measured in meters. Find the slope of this curve where it meets the right pole. So this is 0 and this is 7. So they're asking us, and then find the angle, blah, blah, blah. So find the slope of this curve where it meets the right angle, which means when x is, right? Meet the right pole, I'm sorry, when x is 7. So let's copy the function. So this is problem 51 on 263. So here's the function. F of x equals, or y, same thing, to 20 hyperbolic cosine of x over 20 minus 15. 15 is outside, has nothing to do with hyperbolic cosine. So first they're asking us to find the slope of this curve where it meets the right pole. what do I have to find first? We find the derivative. Good. So then f prime will be, remember hyperbolic cosine prime is not negative but positive. So this is 20. Hyperbolic sine of x over 20. The negative 5 prime is 0, but I haven't finished. Times what? 1 over 20. Well, we'll cancel with the 20 in front because this is outside of the function. So the answer is hyperbolic sine over 20 for the derivative function. But they are asking us to determine the slope when x is 7. So we have f prime of 7, which is hyperbolic sine of 7 over 20. It is possible that we have this function in the graphing calculator. Or here is the second option. So let's take a look. So 0.5 times, in parentheses, e raised to, careful, 7 over 20, 7 divided by 20. I'm sure in the newer calculators this function is somewhere. In parentheses, negative 7 divided by 20. Close the parenthesis for the top, close the parenthesis for the whole thing, and press enter. And we got 0.36 approximately. Measurement unit. So it's a rate of change when x is 7, right? So both x and y are measured in meters. So the rate of change of y with respect to x. So it's meters per meter. Meters for the measurement unit for the top and meters for the measurement unit for the denominator. Now, I have not tested to see if there is hyperbolic sine in this software. I don't know. Maybe your more sophisticated calculators has it. I'm not sure. Maybe you come up with the answer next time for me if you look it up, or I will look it up. Okay, part B. Find the angle theta. So part B is this situation. That's the angle theta. Find the angle theta between the line and the pole. This is between the line. This is the line and the tangent at that point, and the pole. This is the pole. Okay. Do we know the slope of this line? I'm going to write m tangent. Do we know it? We just determined it, right? So that is our 0.36. Okay. But the slope of this line is basically this angle, not that angle. That is the slope. In other words, rise over run. That's what I meant to say. Rise over 1. So tangent of this angle alpha is, tangent alpha is rise, which is this, rise over run, which is 0.36. Okay, so then how do I determine this angle? from 90 degrees, basically from pi over 2, I have to subtract this angle, alpha. I know that its tangent is 0.36. So from pi over 2, I subtract alpha, pi over 2, minus. How do I determine alpha if I have tangent alpha equals 0.36? Arctangent, very good. Arctangent 0.36. And that will give us the angle in radians. You can say, I don't want the angle in radians, I want the angle in degrees. That's fine too. So you have 90 then minus arctangent 0.36, and this will be in degrees, and this will be in radians. So let's go back. So make sure that the mode is in radians. If the mode is in radians, then we have pi over 2 minus arctangent, which is right here, second and tangent inverse of 0.36. And I'm going to call the previous answer. And that's in radians. I can change this into degrees, or I can say 90 minus, I change the mode into degree mode, and then I say minus arctangent, and in parentheses 0.3571. I cannot no longer use the previous answer because it will take this one instead. Okay, and that is 70 degrees. Which makes sense because 1.22, because one radian is 57 degrees. So this angle theta, so this is theta in both cases. So theta equals 70 degrees or 1.23 radians. So we have about half an hour. Can I go to the section from page 265 and just choose some examples from here? Now feel free, if you have your book, feel free to choose. Let's look at some differentiation first of all, and then we move on to other problems. Would you like to look at implicit differentiation again?
Mm-hmm.
Yes? Okay, very good. So in that case, we can continue with 25 on to 65, which is sine of the product xy equals x squared minus y. So let's work on it for 1 minute. Ready? So the left-hand side and the right-hand side, be careful. This is the sign is outside, and then x times y is a product. So this is, first of all, cosine xy, but times, very careful. Remember, we are differentiating the inner function, which is a product. So when we differentiate a product, we have to get a sum. So the first function prime times the second one, so the first function prime is 1 times y, but plus x times dy over dx. The right-hand side is just 2x minus dy over dx. Do you agree with this? But we cannot remove dy over dx from inside brackets before we distribute. So we have to distribute cosine to both. So we have y cosine xy plus x cosine xy. I'll erase that. And then move terms around. And this is 2x minus dy over dx. Now, I swallowed something here. Dy over dx. So this term has to move, or you move this term here and this term there. So x cosine xy minus 1 dy over dx equals 2x minus y cosine xy. Do you agree with this so far? Yes? So, yes, of course. So x cosine y, of course, thank you, my apologies, plus 1 equals 2x minus x cosine, that's correct, and then 2x minus that. Very good. Now I doubt myself on every step once I make one error. So 2x minus y cosine xy and x cosine, of course, xy plus 1. So that was okay. X cosine. Now I have to check everything. Once I make an error, I don't trust myself. Okay, so I move this, and yes, it's positive. I factor out dy over dx. I move that, it's negative. Correct. So 2x minus, that's correct, over this. So this is an x and a y here. Cosine xy plus 1 with x in front. Sorry about that. Okay. Do we want to differentiate more or look at other types of problems? Find the equation of the tangent line to the curve at a given point. How does that sound? Like 58 or 59? Which one? Okay, 58. 58 on 265. We have y equals x squared minus 1 over x squared plus 1. The point is 0, comma negative 1. Don't trust anything. Yes, it is 0, comma negative 1. When I plug in 0, I get negative 1. They want us to find the equation of the tangent to the curve at the given point. So that's the curve, and that's the given point. So let's work on this for 1 minute. I'm so sorry the first video is going to be over an hour. I forgot to stop it on time, so I uploaded it. So then what we need to do next is find the derivative, right? And this is the quotient rule. The top prime is 2x times the denominator minus the top times the denominator prime over x squared plus 1 squared. Do you agree so far? Don't try to simplify anything other than factor out 2x. So this is 2x, and then x squared plus 1 minus x squared plus 1. It cleans up quite nicely because these two go away. So the simplified form is 4x over x squared plus 1 squared. Do we agree with that part? So of course now we have to plug in we have to plug in 0. So 0, 0, so it's 0. So then we have the slope is 0 at the point P. So now in order to find the equation of the tangent line, I have to write the point slope form as y minus y1 equals the slope times x minus x1, where the slope is 0, x1 is 0, and y1 is -1. So all this side is 0, y plus 1. So y plus 1 is 0, or y equals -1. So at that point 0, -1, the tangent to the graph of function y, or f of x, is -1. Questions? Questions? Is this okay? Okay, let's look at a word problem now. You want to look at the cost function again. Would you like to look at some differentials? Which one? Both? Very good. Okay, so let's look at 92 on page 267. The cost in dollars of producing X units of a certain commodity is C of X equals 920 plus 2x minus 0.02 x squared plus point, I think I see 4 zeros. Correct me, please. I'm going to look in a second. Yes, I see 407 x cubed. First question, find the marginal cost. What does the marginal cost represent again? The derivative. So let's find C prime. So C prime is, can anyone give us C prime? I would arrange it in descending order when I write it. So I will have 0.0021, no, it's 3 zeros. 3 zeros, 21 x squared minus 0.04x and plus 2. I will write it in the correct order. In part B, they want us to find C prime of 100. What does C prime of 100 mean? Yes, the rate of change of the cost dollars per unit when they manufacture 100. What does it predict? It predicts the cost of item number 101. Very good. So 0.00021 times 100 squared minus this times 100 is 4 and plus 2. So 4 zeros, 2, 4. 2.1 minus 2. 0.1. Measurement unit. Remember, it's the rate of change of cost per unit. This is an estimate. This is not the exact cost. How will I determine the exact cost for the item 101? So that's the next question. Compare C prime with the cost of producing the 101st item. How do I determine the exact? So this is estimate. A good one, but an estimate. What is the delta C, which is the exact cost for item 101 by C of 101 minus C of 100. Very good. So I'll punch it in the graphing calculator. I'll punch in the function and y equals clear everything. So we have 920 minus no y 120 920 plus 2x and minus 0.02x squared and plus 4 zeros 7 x cubed. And now I go to second and table and I plug in 101 and I plug in 100. And I go and highlight to see what's happening here. Okay, so this is 990.10107 minus 990. So the exact answer, the cost for the 101st unit is $0.10107 per unit. So is 0.1 close enough for you? Yes, very good. Okay, let's approximate. In problem 103, we're asked to find an approximate using differentials, the cube root of 1.03. So use differentials. So for this problem, we have to remember that f of x plus a little bit is approximately what? This is a crucial definition. F of x plus, and remember this is dy, which is composed of a product, right? It's f prime of x dx. Good. So in this situation, we have to identify f of x. We have to identify x, dx, and find f prime. So let's work on this problem for a minute. Let's do it together. Let me know if you need help. Can anyone identify the function for us? Which is? Very good. Can anyone identify x for us? 1. Very good. Can anyone identify dx? And it better be small. 0.03. Can anyone give us f prime now? Remember, this is x to 1/3. It's easier to differentiate. So it's 1/3 x to negative 2/3. And now you can go back and write this. 3 the cube root of x squared. That's okay. Now we're putting all these pieces together. The left-hand side is this. I have to copy exactly what I have. So the cube root of 1.03, approximately. F of x. So in f of x, I plug in 1. What do I get? How much? 1. Very good. Plus. In f prime, I plug in 1. What do I have? Yes, awesome. 1/3. Times dx. How much is dx? That's it. So this is nothing else but 1 plus, when I simplify by 3, I get 0.01. Would you have imagined to get the cube root? Okay, so let's check with the graphing calculator. Let's go to clear, whatever. So we want to verify that the cube root of 1.03, and you know me, I'm old-fashioned, so I prefer it this way, 1 divided by 3. And we get 1.0099, and we got 1.01, which is a very good approximation. Okay. Like this one? Yeah. We can make one up. Let's make one up. What would you like to estimate? Using differentials. Okay, I would like to estimate 1 over the square root of 100.01. So we know this is the same definition, f of x plus f prime of x dx. And we have to find f of x, we have to find x, we have to find dx, and we have to find f prime of x. Once we have all these pieces, we'll put them together in the definition, the left-hand side being 1 over the square root of 100.01. Would you like to work on this for a minute or not? Can anyone give us the function? It's not a nice function. Right? Is? Yeah, it's not a nice function. But x is nice. What is x? Very good. What is dx? What is f prime? That's not nice, because now we have to write x to -1/2 prime, -1/2 x to -3/2, or -1/2 the square root, so the square root of x to the third. I would have written it as 2x the square root of x, to be exact. So now we have all these pieces, so let's put them together. 1 over the square root of 100.01 is approximately, this is not exact as we know, 1 over the square root of x, where x is 100. What is that? 1 over 10. Very good. Now look at this as a minus. I have 100 here, but the square root of 100 is 10. So 100 times 2 is 200, times 10 is 2,000. But times 0.01. If you find the least common denominator, which is 2,000, you will multiply this by 200 and subtract 0.01. So 200 minus 0.01 is what? 1.99? I'm sorry, 199.99 over 2,000. So we want to be sure, of course, and we go to 1 over the square root, blah, blah, blah. For me is 100.01 raised to, in parentheses, -0.5. And now 199.99 divided by what we got is 2,000. Which is pretty good. I mean, 1, 2, 3, 4, 5. 4-digit accuracy. You don't have to calculate this. This is good enough. Or what I would do, I would not leave decimal numbers in a fraction. I multiply top and bottom by 100, and that's not going to make any difference. So this is your answer. You don't have to approximate it. You don't have to put in the calculator. I did because I wanted to make sure that there was no error and we didn't omit anything. But you don't have to do that.